So today we're going to talk about functions. We're going to talk about functions. Now, a function is simply, it's a rule. A function is a rule that takes an input and assigns a specific output. So we might as well write the definition down here to begin with. So the definition of a function, it is a function. So a function is a rule that takes an input. So an input could be a number, or it could be a letter, or it could be a name, and assigns a single output. Now it's useful to think of a function like a machine. So the machine could take some input. Here we'll denote our input with green. So it takes some input, and this input goes into this machine or this mysterious little box here, and then the box considers it, the machine considers it, and ponders it, munches on it, and then returns some output. And the important thing is that it's not many outputs, it's a single output. Now, you might have seen some functions before. Most of the time in the preliminary course, we'll deal with functions that are in the form of equations. We're going to go through about six different ways that you can, there are many different ways of describing a function. We're going to examine 6 different ways to describe a function. There are many more, but these are the ways you'll likely encounter. So the first one is that you often see equations, so equations that describe specific functions. So an equation you might see is, for instance, y equals x squared. Alternatively, another form of writing this, it could be f of x equals x squared. So here the x is the input. These two, these are the same functions, they describe the same rule, and what they do is they take a specific input here, which is the x, and then from that input they get something. That something that's churned out is some output. So for instance, if we were to take this specific function, what we do is, let's say we want to find, we want to substitute the value here of 2. So what happens when we put 2 into this little box, this rule? Well, what happens? Well, it thinks about it for a while, and it goes, well, what is 2 squared? And we know that 2 squared is 4. So it produces a single output. We put 2 in here and we get 4 out here. This is in and of itself a function. But functions don't always have to be equations. Many functions are described by graphs. This is another way of describing a specific rule or a function. And so we might have a graph that looks something like this. Imagine we have our y-axis and we have our x-axis. And let's consider the graph of y equals 2x. So let's call this y equals 2x. Now this, if we just label our axes here, this is the x-axis and this is the y-axis. So this describes a particular rule. If you give me some input, some x here, let's say this is x equals 1, then this rule will produce some y. So x equals 1 goes up here. It will produce, if we put the 1 in here, it will produce some output, which here is 2. So again, if we were to describe this in these terms, if we put if we put the value of 1 in as our input, what we get at the end is we get some output, and it's just a single output, and that output is 2. So a graph is also a type of function. But there are other functions that you might not have heard of. The third type of function is the mapping of sets. So you might encounter a particular function rule which looks something like this. You might get you might get a number of pairs. So for instance, imagine that you have 3 pairs. So what these pairs do, they say that for any particular inputs here, we'll call them x's. So if you give me an input 1, then this rule says that the output will be 3. Or if you give me an input of 0, the output will be 0. If you give me an input of 2, the output will be 6. Another way of saying that, if you give me an input of 1, then this machine will examine what that one and churn on it for a while, and then it will say, oh, well, you've given me 1, well, I know the output for that has to be 3, so the function assigns the value of 3. So again, another simple function. Another way of looking at functions, you could look at tables. So tables often describe a function. You could have a table, say, of x and y values. So imagine we've got our table here. Our neat little table, and imagine that we have, say, -1 and 1 is one pair, 0 and 0 is another pair, and 1 and 1 is a pair. Well, again, we've got these inputs. Here are the inputs, these x inputs, and these are each assigned a specific output. So if we were to put this input in here, say 0, into this function, so this input here, then the function, this little machine, would look at this rule and determine that 0 is the output that's associated with this input. So we would get a, oops, let's do that in pink, we would get an output of 0 here. Okay, now I said there were 6 before, so there are 2 more to go. The 5th one is that you might get a relation diagram. A relation diagram. So a relation diagram, again, assigns a set of inputs, a set of outputs. So for instance, imagine that we have 2 sets. One set looks like this, one set looks like this. And just to show you that we don't necessarily need to use numbers or even words here for functions, imagine that we have a square and a circle and a triangle. And imagine that these things map to, say, A, B, and C. So these are our inputs and our outputs, and imagine that this is the way that they're mapped. So this is the function rule that specifically describes how these 2 sets are related. So we can just draw these little arrows here. So what happens here is that these, again, are our inputs. If we input a square, then our function rule says that we should have an A as an output. So let's do that. Let's say we put in a square here, so not a number or a letter, but a square. Well, this function rule thinks about it for a while and says, oh, let's have a look here. Oh, the output should be A. So that's the 5th type of function that you might face. Now the 6th type is simply expressions, or I'll call them words here. So a worded expression. So you might get some expression that you might need to evaluate whether or not it's a function. This expression might take the form of, for every x, y is twice x. So that's a rule. That's definitely a rule that we can use to determine inputs and outputs. So the input here again would be the x, and the output would be y is twice x. So the output here is y. Or more specifically, we'd say that the output is y, and this rule is that y is twice x. So if we were to put in some value of x here, let's say x is 2, then our little machine would say, oh, well, let's refer to this function rule. Y is twice x when x is 2, so y is twice 2, so that's 4. So here, y must be 4. So these are all examples of functions. And these are really the only 6 that you'll ever come up against in textbooks that you're using.